All right, if you're getting ready for a SQL interview, you know that feeling, right? The pressure is on. But today, we're going to go way beyond just memorizing syntax. We're going to get into the logic. What interviewers are really looking for when they ask you to write a query.
So the big question is, are you ready for that next technical screen? Because by the end of this, you're not just going to have some canned answers. Nope. You'll have a whole new way of thinking through any problem they can throw at you. And honestly, that's the real secret sauce right there. The best candidates, the ones who get the job, they show they don't just know what to type, they know why. They see SQL for what it is, a powerful problem-solving tool. So let's start with the absolute must-haves.
Okay, first up, mastering data manipulation. You gotta have these foundational skills down cold. Every single data role needs them. We're gonna start with probably the most common operation of them all, joins.
Let's talk about the inner join. The easiest way to think about this, it's like a Venn diagram. It only brings back the records that are in that overlapping middle part, the ones that have a match in both tables you're connecting. If a row in one table doesn't have a partner in the other, sorry, it gets left behind. Okay, to see this in action, let's imagine we've got two tables. Here's our first one, a simple list of employees. We've got their ID, their name, and a department underscore ID. And here's table number 2. This one just maps those department IDs to the actual department names. Now keep your eye on Department 104, Sales. It's going to be pretty important in just a second. So, what happens when we run an inner join on these two tables? Boom. We get this nice, clean list of our employees and their department names. But wait a minute. Notice who's missing. The sales department. Why? Because no employee was assigned to it. It had no match in the employee table, so poof, it gets filtered out. Simple as that. All right, on to another classic interview scenario. You're handed a messy table, and your first task is to clean it up. The number one problem? Duplicate entries. So you've got a few ways to tackle this. First, there's select distinct. It's a quick and dirty way to see the unique rows, but let's be clear, it doesn't actually delete anything. Then you've got group by, which is fantastic for finding and counting the duplicates. But the real pro move, the one that really shows you know your stuff, is using the row number function with a common table expression, or CTE. This lets you assign a number to each row within a group of duplicates, like 1, 2, 3. And from there, it's super easy. You just tell the database to delete any row where that number is bigger than 1. Problem solved. Okay, with those fundamentals locked down, let's level up. These next few concepts, well, these are what interviewers use to really separate the good candidates from the great ones. This one trips up so many people. Where versus having. Here is the absolute easiest way to remember it, I promise. Where filters individual rows before you do any aggregation, like a count or AVG. But having filters the groups themselves after you've already done that aggregation. So think of it this way. Where is for the raw data, having is for the summarized, grouped up results. Speaking of advanced functions, let's talk about ranking. Specifically, let's look at two window functions that seem almost identical, but have one critical difference. Ranking and dense rank. Okay, here's our sample data. It's super simple. We're going to rank this based on the values in that first column. And you'll notice we've got a tie, 2 rows with the value 10. All right, so when we use rank, those two 10 values both get a rank of 1. That makes perfect sense, right? But here's the catch. Look closely at the next rank. It doesn't go to 2. It jumps straight to 3. Rank always leaves a gap in the sequence right after a tie. Now let's try the exact same thing, but with dense rank. Once again, the two tied rows both get a rank of 1, but this time, look at that. The very next row gets a rank of 2. There are no gaps. The ranking is, well, dense. So knowing which one to use really just depends on whether your problem can allow for gaps in the sequence or not. This last section, this is what truly separates the senior candidates from the juniors. It's about understanding not just what the code does, but how the database actually executes it. It's about knowing why some queries are blazing fast and others, not so much. Let's dig into indexes. First up, a clustered index. The best analogy for this is a dictionary. Why? Because it doesn't just point to the data, it physically sorts and stores the actual data rows in that alphabetical order. And because the data can only be physically stored in one order, a table can only have one clustered index. That's it. A non-clustered index, on the other hand, is like the index at the back of a textbook. It's a totally separate structure. It's just a list that has the keyword and a pointer, a page number, to the location of the actual data. And since it's just a separate list, you can have a whole bunch of them. A single table can have many non-clustered indexes. And finally, a truly great candidate understands the type of database they're working with. Are you on an OLTP system? That stands for online transaction processing, and it's built for tons of fast, constant transactions, like updating a customer's address. Or are you on an OLAP system, online analytical processing, which is built for heavy-duty analysis with really complex queries? Knowing the difference shows you're thinking about the big picture, performance, architecture, not just the one query sitting in front of you.
So we've covered a lot, right? Data manipulation, advanced queries, and even some database architecture. So what's the one core principle you absolutely need to take with you into that interview?
I mean, what's the one big idea that really ties all of this together?
Is this: stop trying to memorize code, start trying to understand the logic of the data itself. An interviewer isn't just checking your syntax, they're testing how you think. So the next time you're faced with a complex problem, don't ask yourself, what code do I type? Ask yourself, what is the story this data is trying to tell me? If you can answer that, you've pretty much already won.